So we want to find the point that works for both. Let me just do this quickly. So we have y equals mx plus b. All right, this is our b. So we're going to begin here. So we begin at 8. 1, 2, 3. Right, this is our x. Right, this is our x. This is our y. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And then we're going to move, right? -4. You can write that as -4 over 1. So we're going to go down 4, right 1. Down 4, right 1. So let's do that. Down 4, 1, 2, 3, 4, right 1. Down 4, right 1, etc., etc. You could also go up 4, left 1, so on and so forth. And then we would just draw this guy right here. All right, and second guy, again, y equals mx plus b, so this is our m, it's a 1. This is our b, it's a 7, so we're going to begin and move. So begin at 7, 1, 2, 3, 4, 5, 6, 7, right here underneath, of course. And we're going to move. Now, 1 over 1 means we're going to go up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1. Okay, I can also go down 1, left 1, down 1, left 1. And we draw our arrow right there. Here's the problem with graphing. The problem with graphing is, I mean, the good things is it's very nice and easy to see. Very nice, easy to see. Here's the problems. First off, it's slow. You probably already thought that. Second off, it doesn't always work so nicely. So let me zoom in here. Where is the solution? It's here, but it's not on any one of these points. It's just kind of floating in here. So it's some kind of fraction. I don't know what the x is. I don't know what the y is. I mean, the x looks like it's somewhere between, right, 0 and 1. And our y, if we back up again, this would be 1, 2, 3, 4, 5, 6, 7, somewhere between 7 and 8. So somewhere between 0 and 1, and somewhere between 7 and 8, but we don't know. It's hard to really see. We need a better way, an algebraic way to solve these. Okay, so we've discussed why graphing is kind of not always the best way to solve systems. Remember, a system is anything with 2 or more equations. We talked about how solving a system means finds the ones that work for both, right? Find x and y that work for both. Okay? Now, we did it by graphing before, but as we just saw, graphing is slow, and graphing doesn't always give you the right ideas. So the first one we're going to talk about is something called substitution. And my question to you is, do you guys know of any pair of identical twins that look so much alike, like maybe some of the ones in these pictures? These twins look so much alike that you can't tell them apart, right? If they were in your class, well, they're not young like this, but do you ever have any twins that you know where one could show up instead of the other to class and you would never know the difference, right? That's what we're going to talk about today. That's substitution. When two things are exactly equal, you can substitute one for the other and you would never know the difference because they're so alike. All right, so that's what substitution is. So the steps to solving by substitution, there's 3 steps. Let's write these down. 3 steps. Okay, first is to isolate. Go and write that down. Isolate x or y. Isolate x or y. You want to isolate it. Okay, that's the key. Then you want to substitute. This is the key step. Substitute to the other equation. Right? Substitute to the other equation. And then step 3, you want to solve. Okay? Just go ahead and box that up. Right? Again, the main 3 steps, you want to isolate x or y, it doesn't matter. Then you want to substitute to the other equation and then solve. All right? Isolate, substitute to the other, and solve. So Let's take a look at number 1. So number 1, we're going to solve by substitution. And remember, we could solve this. I mean, look, this is y equals mx plus b. You could graph this. This is standard form. You could find the x and y intercepts, but we're trying this by substitution. So first off, let's isolate x or y. So is anybody by themselves? So look, x and y are together here. No. X has the 10 with him, but look here, y. Look at y is already isolated. Y is already isolated, so we're done with step 1. We're done with step 1. Okay, step 2, we want to substitute to the other equation. Now this is the key. When you have y equals something, think of it like the twins. Y equals x plus 10, right? Y equals x plus 10. These are my two twins, at y and x plus 10. They are exactly alike. They're equal, right? So one can show up instead of the other, and no one knows the difference. Okay, so we're going to take this guy right here, and we're going to substitute right there, right? See, you have a y here, but we know that y equals x plus 10. So instead of writing a y here, we can write x plus 10, and no one's going to know the difference because they are equal. They're the same. So let's take this equation right here. We're going to rewrite it. Negative 2x minus. Now instead of writing a y here, instead of writing a y, leave a big space here, we're going to substitute. We're going to substitute, and we're going to write in this x plus 10. Okay? Again, what we just did here, instead of writing y, we wrote x plus 10. Why can we do that? Because y is the same as x plus 10. They are equal, so you can substitute. And now look, we have only one variable, so we can solve now. We're going to get negative 2x. We've got a minus here, so I'm going to distribute. Let's go ahead and draw the arrows here. Distribute, that's going to be negative x. And this is going to be a negative 10. This equals 2. Negative 2x minus x, that's negative 3x minus 10 equals 2. All right, we're going to solve for x. So let's go ahead and add 10 to both sides. Right? That's going to give me a 0 pair right here. So we get negative 3x equals, what is 2 plus 10? 12. All right, then we get x by itself. We want to divide by negative 3. Negative over negative makes it positive, so we're going to get x equals 12 divided by 3 is 4, but we have a negative, so x equals negative 4. Cool, so we solved for x. Now, to find y, all you have to do is take this guy and plug it back into either equation. It doesn't matter. You could plug it in here or here. Just find the simpler one. Which one looks more simple? To me, it looks like this top one is a little more simple. So we're going to take this guy, plug it in right there, right here for x. So y equals x plus 10. Instead of this x, we're going to write y equals negative 4 plus 10. Negative 4 plus 10. And what is negative 4 plus 10? Well, 10 minus 4, y equals 6. Okay, so our solution, remember this is a point, this is not two different answers, this is one point. Our solution is negative 4, comma, positive 6. This is our solution. This is where, if we were to graph these two, this is where they would cross. X equals negative 4, y equals 6. Okay, so again, we're going to isolate, substitute to the other equation, and solve. Okay, so come down with me, we'll try a few more here. Number 3, so again, let's take a look here. Isolate x or y. So let's see, is this x by itself? No, he's got the 3, he's got the 4, y here, so no. This x has all these 3's here, but oh, look, again, y is isolated. Y is already isolated, so we're finished with this step. Now we're going to substitute to the other equation, right? So again, we know that y equals 3x plus 3. They're equal, right? These are twins. y is the same as 3x plus 3. So anywhere I see this y, I can write 3x plus 3 instead, and no one knows the difference because they're the same. So number 3, let's go ahead and do that. So I'm going to rewrite, remember we're writing the other equation. So we're going to do this equation. 3x minus 4 times, again, now instead of writing y is twin, y is equal to 3x plus 3. So let's go ahead and write that. 3x plus 3. And then that equals 6. Right? And now look, all we have is x's here. Now we can solve this. We couldn't solve it with 2 variables before, but now we can solve step 3. So let's go ahead and do that. So 3x minus, all right, so let's go ahead and distribute here. Negative 4 times 3x, that's 12x. Sorry, that looks like the negative. 12x. And then don't forget to distribute here. So negative 4 times 3, negative 4 times 3, that's a negative 12, equals 6. Okay, I mean, you could draw the barrier, oops. You could draw the barrier if that helps you to keep things straight. It's definitely not straight. Let me use the straight tool. My hand is not going to be writing very well. All right, so I want to combine like terms. These are like terms. 3 and negative 12. That would be different signs subtract. 12 minus 3 is 9. 9x, but we want to take the sign of the bigger number, negative 9x. All right, so I want to get x by itself. I want to get rid of this, but first I want to get rid of negative 12. What's the opposite of negative 12? Positive 12. So we're going to add 12 to both sides. Add 12 to both sides. That's going to be a 0 pair. 0 pair. So we're left with negative 9x equals 6 plus 12. 6 plus 12, I should have written it over here. 6 plus 12, that's going to be 18. All right, how do I get this x by itself? Again, I divide by negative 9. That makes a 1 over here. Negative over negative makes a positive. So x equals 18 divided by 9 is 2. And we have a negative, so x equals negative 2. X equals negative 2. All right, so we've got x. All we need to do now is to find y. All right, we need to find y. How do we do that? Well, we can plug into either equation. I could plug in right there, or I could plug in right there. Either way, pick whichever one looks more simple. I'd say this looks more simple, so let's plug in here, but you could plug in here, you get the same answer. So y equals 3x, but what do we think x is? X is negative 2 plus 3. So 3 times negative 2 is negative 6 plus 3. Negative 6 plus 3 is negative 3. So our x is negative 2, our y is negative 3, and this is our solution. This is the one that would work for both. If we were to graph these, it would work for both. Now, again, we won't do this every time, but let's go ahead and check this real quick. Does that actually work? X negative 2, y negative 3. Come back up here real quick. So if we plug in a negative 2 here, negative 2 and negative 3, does that work? Negative 2, negative 3. Sorry, it's so small here. 3 times negative 2. What is 3 times negative 2? That's negative 6. And what's 4 times negative 3? 4 times negative 3, that's negative 12. Negative 12 here, but you have a negative, negative. Negative times a negative 12, or minus a minus 12, excuse me. Minus a minus 12 is plus 12. So negative 6 plus 12. Negative 6 plus 12. Does that give me 6? Well, 12 minus 6 is 6, so yes, that works. And if I check over here as well, plug in, let's see, what do I plug in for y again? Y is negative 3, and x is negative 2. So let's try that, negative 3 for y. Negative 2 for x. 3 times negative 2 is negative 6. And that's a plus there. It's kind of hard to see. Negative 6 plus 3. Does that give me a negative 3? Well, what's negative 6 plus 3? That different sign subtract? Yep. That does work as well. So again, this is the point that works for both the top and the bottom equations. Alrighty, let's try a few more here. Think we're getting pretty good at doing the basics. Let's try another one. So again, our first step, you want to isolate a variable. X no, Y no. This guy again is isolated. It's not always going to be Y. I don't know why it's always turning into Y here, but Y is isolated. Who does Y equal? Y equals negative 2x minus 6. These guys are my twins. So anywhere I see this Y, instead of writing a Y, I can write this. Negative 2x minus 6 can show up instead, and no one would know the difference. So step 2, we're going to substitute to the other equation. So we're going to plug in right here. So the other equation, negative 5x plus 2 times, instead of writing a y, we're going to write his twin, negative 2x minus 6. Negative 2x minus 6, and that equals negative 12. All right, so we got some solving to do here. I'm going to draw my bar here because I'm finding that to be helpful with these types of equations. First I have to be able to draw it though. All right. So let's go ahead and distribute. So what do we get here? Negative 5x plus positive times a negative. 2 times negative 2. 2 times negative 2, that's going to be a negative 4. So it looks like this is actually going to be a negative. You can erase that or just put a negative plus a negative. That's fine too. Negative 4x. And 2 times negative 6. 2 times negative 6. That's going to give me a negative 12. Okay, so on this side of the fence, I want to combine like terms. So that's going to be negative 5, negative 4. That's going to be same sign, keep, and add. So that's going to give me a negative 9x, right? Minus 12 equals negative 12. All right, I want to get rid of this negative 9, but first I want to get rid of this 12. So let me go ahead and add 12 to both sides. Add 12 to both sides, so negative 12 plus 12, that's going to give me a 0. So negative 9x equals, oh, looks like we have another 0 over here, right? This is another 0, so we get 0. So to solve, we divide both sides by negative 9. And, of course, over here, this is just a 1, so x equals 0 divided by negative 9. Well, 0 divided by anything is just 0. So x is 0 for this one. X is 0. All right. Well, how do I find y? Again, once I have this x, I could plug it into either one. I could plug it in right here or right here. Whichever one looks more simple. Again, I like this one, so I'm plugging into this top one, but you could plug into the bottom one. It doesn't really matter. We get y equals negative 2 times, what do we think our x is? We think our x is 0. So plug in a 0 here, minus 6. What is negative 2 times 0? That is just 0 minus 6. What is 0 minus 6? Y equals negative 6. All right, so that is our answer. It is 1 point. We think our point, where do these two lines cross? It would be 0, comma, negative 6. 0, comma, negative 6. All right, and just briefly, let me just plug it in here. So we think that this is a 0. We think this is a negative 6. Does that work? 2 times 0 is 0. 0 minus 6, negative 6. Yep. And we think this is a 0. And we think this is a negative 6. So negative 5 times 0, that's 0. 2 times negative 6, that's negative 12. Yep. So again, the point where these two lines cross is 0, comma, negative 6. All right, so now let's try, we're on the back side. Let's try a few more now. We're solving by substitution. Remember, our first step is to isolate either x or y. Sorry, or. That looks bad. X or y. Then the second step is to substitute to the other equation, right? To the other equation. And then step 3, solve. Okay, so isolate either x or y, substitute to the other equation, and then solve. That is substitution. Isolate, substitute, solve. So for the first time here, number 7, let's look at number 7. Nobody, let's look at this. X is not by himself, he's got this guy. Y is not by himself, he's got this guy. This x is not by himself, he's got negative y, negative 2y here. Y is not by himself either. Nobody is isolated. Nobody is isolated. We have to do the work ourselves. The next trick is to look and see, well, who is the easiest to isolate? Who is the easiest to isolate? And in this case, it looks like this guy is the easiest to isolate. Why? Because all the other ones have numbers in front, and that's going to mess things up. So let's isolate x. Okay, let's isolate x. So let's write that out. X minus 4y equals negative 10. How do I get x by itself? Well, who's hanging out with x right now? I mean, you could draw a little bar if you want, but we're not going to use it too much. Well, it's this negative 4y. How do you move this negative 4y to the other side? You got to do the opposite. So what is the opposite of negative 4y? Well, it is positive 4y. So we're just going to add 4y to both sides. This becomes 0. So we're going to get x equals, these are not like terms. See how one has a y, the other's just a number? So you're just going to write x equals 4y minus 10. Look, now we've isolated. Look, x is by himself. X is by himself. So now we know that x equals 4y minus 10. Right? X equals 4y minus 10, which means that these guys are twins. Anywhere I see x, I can write 4y minus 10. Anywhere I see 4y minus 10, I can write x. So we're going to substitute now. We're going to substitute. We used this equation here. So we're going to substitute to the other equation. So we're going to substitute right here. Where I see x, my twin is going to show up instead. So we're going to use the other equation right here. Let's write it out. Negative 3x, minus 2y equals 2. I forgot to substitute, but that's okay. So right here, instead of x, let's rewrite it. Instead of x, we're going to have the twins show up. 4y minus 10. Minus 2y equals, and again, that's a 2. Okay, so this is the only extra step. We had to do an isolating step, and then we substitute, and now let's just go ahead and solve. So I'm going to do my little, if I could ever get that straight, my little barrier here. Okay. So let's distribute here and here. So negative times a positive, that's a negative 12y. Negative times a negative, negative 3 times a negative 10, negative times a negative is a positive 30, minus 2y equals 2. Okay, let's go ahead and keep working here. Let's see a negative. I can combine like terms. These are both y. That looks like same sign, keep and add. Same sign, keep and add. That's a negative 14y plus 30 equals 2. All right, so next up, I'm going to subtract 30 from both sides, right? Subtract 30 from both sides. That gives me a nice 0 pair here. So negative 14y equals, let's see, these are different signs. So different signs, subtract 30 minus 2, 28. Take the sign of the bigger number, negative 28. All right, so our last step to get y by itself, divide by negative 14. Divide by negative 14. We will get, this is going to become a 1, so we're going to get y equals 28 over 14. How many times does 14 go into 28? 14 goes into 28 2 times, and a negative over a negative makes a positive, so this is a positive 2. So y equals 2. Y equals 2. Now, we're not done yet. We're not done yet. We can actually take this y now, and we can then plug the y into anywhere we see fit. We could plug the y in here. We could plug the y in here. Or we could even plug the y in here. Let's just pick the one that looks the most simple. I'd say this looks the most simple. So you could plug it in right here. So x equals 4 times y. But we think y is 2. So we'll go and write that. 4 times 2 minus 10. Okay, so x equals 4 times 2 is 8 minus 10. What is 8 minus 10? Well, 8 minus 10 is 2, but the 10 is negative, so negative 2. Right? Take the sign of the bigger number. So our solution is negative 2, comma 2. Negative 2, comma 2. All right, let's check to see if that actually works. Plug in a negative 2 here for x, and plug a 2 in here for y. This is some time. So negative 2, what's 4 times 2? That's 8, so negative 2 minus 8. Negative 2 minus 8. Does that give me negative 10? Same sign, keep and add. Yep. All right, plug a negative 2 in right here, negative 2, and plug a 2 in right here, just times. So negative 3 times negative 2. What's negative 3 times negative 2? That's a positive 6. And 2 times 2 is a 4, so 6 minus 4. Does 6 minus 4 give me 2? Yep. So this is the solution. This works for both the top guy and the bottom guy. Negative 2, comma 2. All right. Let's zoom out a little bit. Let's take a look at number 9. So remember, our first step for number 9, isolate. You want to isolate one of these guys. Well, who is the easiest to isolate? No one. This guy's not by himself. 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 No one is isolated, but somebody has no coefficient. This guy's the 3. This guy's the negative 2. This guy's the 3. This y is probably the easiest to isolate. So let's isolate first, and then we'll substitute. So come down here with me, number 9. All right. So let's isolate y. All right, let's isolate y. So let's rewrite this. 3x plus y equals 2. All right, so how do I get y? How do I get y to be by itself? Well, you have to ask yourself, who is y hanging out with? Y is hanging out with 3x. So how do I get this 3x over here? You have to do the opposite. So we're going to subtract. Boom, that's nice. Subtract 3x, right? Subtract 3x from both sides. So that's going to give us a 0 pair right there. And we're going to get y equals. Now, again, these are not like terms. They are not like terms. We cannot combine them. So we just get negative 3x plus 2. And there we have it. We have isolated y. Y is by himself. So you can kind of circle these if that helps. Y equals negative 3x plus 2. These are my twins. Anywhere I see a y, I can write negative 3x plus 2 because they're exactly the same. All right, so we have isolated y. Remember our second step is to substitute to the other equation. Substitute to the other equation. So let's go ahead and do that. All right, so we used this equation right here. So let's substitute into this equation. So we have y equals. So right here, we're going to substitute in for y. So let's rewrite this top equation. So 3x minus 2. Now instead of writing a y, who is y's twin? In fact, I'll do it in green just to make that a little more clear. Who is y's twin? Instead of writing a y, I'm going to write this whole thing, negative 3x plus 2. So we have that equals, so we get, what was that, 5 equals 5, right? All right, so now our last step is we're going to need to solve for this guy. So let's solve. Draw my barrier here. All right, let's distribute. So we get 3x. What do we have here? Negative times a negative. Negative times a negative is a positive. 2 times 3 is 6x. And what do we have here? A negative times a negative. Negative times a positive. Negative times a positive is a negative 4 equals 5. All right, so now we combine like terms. 3x plus 6x. Combine like terms, that makes 9x minus 4 equals 5. All right, how do I get the x by itself? I'm going to add 4 to both sides. I'm going to add 4 to both sides, so that is going to give me a 0 pair right there. So 9x equals 5 plus 4. 5, 6, 7, 8, 9. Okay, so how do I get x by itself? I divide by 9. That makes a 1 over here. And x equals 9 over 9, which is the number 1. So x equals 1. Once I have that, remember, I can go ahead and plug into either equation. I could plug it in right there, x equals 1. I could plug it in right there, x equals 1. Or I could plug it in right here. This is a little bit riskier because you might have made a mistake, but we could just do that anyway to save us time. So y equals negative 3, right? Negative 3x. What is our x? We think x is 1 plus 2, right? There's plus 2. So negative 3 times 1, that's negative 3 plus 2. Oops, negative 3 plus 2. What is negative 3 plus 2? That is 1, negative 1. So our solution, we think the point where these two cross is x is 1 and y is negative 1. This is my solution, 1, negative 1. 1, negative 1. All right, we won't check this time. Let's just do one more here, get all the odds out of the way. In fact, nah, let's do this one, number 12. That'd be better because we haven't seen an x for a while. So our first step, remember our first step is to isolate. Isolate x or y. Who is the easiest to isolate over here? Who is by himself? Nobody by himself? No, nobody's by themselves. But someone has no coefficient in front of them. That would be this guy. Right? This is going to be the easiest to isolate. So let's go ahead and isolate x, not y. Let's isolate x. So let's write this out here. X plus 2y equals 1. All right. So how do I get the x by himself? Who's hanging out with x over here? It's this 2y, this plus 2y. Well, how do I move him over? Let's do the opposite, minus 2y here. So I'm going to minus 2y on both sides. Minus 2y on both sides, so that's going to give us a 0 pair. So we get x equals, remember these are not like terms. You cannot combine them. We just get negative 2y, that's a plus 1. Cool, so we did the first step. X equals negative 2y plus 1. I've got my twins. I'm just going to circle them. This is my twin with this. They are twins. Anywhere I see x, I can see negative 2y plus 1. So step 2, we're going to substitute. Substitute to the other equation. So we used, which one did we just used this one, right? So we're going to substitute into the other equation, this bottom one. We're going to plug in for x right here. So instead of x showing up to class, who's going to show up? This guy right here. So let's rewrite this bottom equation. Negative 2x minus 2y equals 2. All right, so instead of, like I said, instead of x showing up to class, we're going to rewrite -2 times, oops, I'll use the green here, times, who is x's twin? Who can show up to class? X is equal to -2y plus 1, right? No one's going to know the difference if -2y plus 1 shows up. Minus 2y equals 2. Okay, so what do we get here? We're going to, let me just draw my little barrier. It's going to help me organize myself. Okay, let's distribute. So negative times a negative, -2 times a -2, that's a positive 4y. Negative times a positive, that's a -2. Minus 2y equals 2. Okay. So let's combine like terms. 4y minus 2y. 4y minus 2y, that is 2y. So 2y minus 2 equals 2. Lots of 2's going on here. That's all right. Let's get this y by itself. We're going to add 2 to both sides. So that's going to become a 0 pair. So 2y equals 2 plus 2. 2 plus 2 is 4. And we're going to divide both sides by 2. And y is going to equal 4 divided by 2, which is 2. All right, so now I've got y equals 2. I can take this guy and I can plug him into here, right? Y, I could plug him into here, y, or I could plug him into here, y. Now that's probably the easiest. Let's use this one. So we're going to solve for x. So I'm going to use this equation right here. X equals -2 times y. What is our y though? We think y is 2 plus 1. So x equals -2 times 2. That's a -4 plus 1. What is -4 plus 1? X equals -3. So our solution is x is -3, y is 2. That is the equation. If you were to graph them, this is where they would cross. All right, you've listened for a long time. Now try a few on your own.